Welcome to Spring LIB.
So from the solution mixture, we will have to find out the possible combination of the positive and negative ions that will form compounds or ionic compounds, and we will have to check if they are water soluble or water insoluble. And for a solid to form a precipitate in an aqueous solution, that solid need to be water insoluble. So let's first write down the compounds we have here. First one is lead acetate. Then we have sodium sulfide. And finally, we have calcium chloride. So first, just make sure that all of these are water soluble. So if we look at the solubility chart of the ions, we'll see that all the acetates are water soluble. That means lead acetate is also water soluble. And we will see that all the alkali metal compounds are water soluble, and sodium being an alkali metal, that means sodium sulfide is also water soluble. And if you look at calcium chloride, all the calciums are also soluble except some exceptions, and calcium is no exception. That means calcium chloride is also soluble in water. So we don't have any water insoluble solid here. That means now we have to we have to uh, find the ions that will be formed from these compounds. So lead acetate will be will be will form lead ion and acetate ion in an aqueous solution, and then sodium sulfide will form Na plus and sulfide ion. We have two sodium here, and we have two acetate here. And calcium chloride will be dissociated as calcium ion and chloride ion. Now we have to look for positive cation anion combination for the solids, and we'll have to look for if they are water soluble or insoluble, and based on that we'll be able to see whether or which solids will form the precipitate in the solution mixture. So first we will combine the lead cation with the rest of the two anions here, sulfide and chloride. And if we write them down, we'll have lead sulfide and lead chloride. Then if we go back for sodium, um, sodium will have two possible combination with acetate and chloride. But as I have already said that all the sodium compounds or all the alkali metal compounds are always soluble in water, so we can ignore the sodium combinations, because sodium compounds will always be soluble in water and they cannot form a precipitate in an aqueous solution. Now we look for calcium. So two possible combination for calcium are acetate, calcium acetate, and calcium sulfide. And so if we can write here calcium acetate and calcium sulfide. Now from these four we have to look for their solubility, and if we look at the solubility chart we'll see that uh, all the sulfides are normally insoluble in water solution or aqueous solution, but there are some exceptions, and lead is no exceptions. That means lead sulfide is insoluble in aqueous solution, and that means it will form a solid precipitate. So lead will be our answer. And if we look at the solubility chart, we will see that all the chlorides are usually soluble, but there are some exceptions, and lead is an exception. That means lead chloride is also insoluble in water. That means lead chloride will also form precipitate so- from the solution mixture we have. Now, as I've already said that um, all the all the acetates are water soluble. That means calcium carbonate is also water soluble, and it will not form as solid precipitate. And then if we look at calcium sulfide, we'll see that most of the sulfides are water insoluble, but there are some exceptions, and calcium is an exception. That means calcium sulfide is water soluble, and it will not form a solid precipitate. So our answer is lead sulfide and lead chloride will form the solid precipitate in the solution mixture given.